Hello and welcome. I wanted to talk about some updates I made to my faceplate mover program. We got it on the actual microscope and it worked pretty well, but we needed to add some features. It was actually a lot more simple than I expected, so I was able to kind of clean up the code and go from there. So, let's first start by going through the interface of it. So one of the things is it starts off the same, but I was able to clean up a lot of the interface because we didn't need a lot of the Xmin and Xmap. I've actually moved that to a configuration file, and I'll talk about that in a minute. But if we take a look at when we update the map, we see that we now have 2 slits, which is how it was set up on the microscope. The original one had 1 slit, and we have 2 slits per aperture, and 2 aperture holes, so we'll have to have a separate configuration file for each. But why don't I show you the configuration file here. So basically, you're just kind of providing the different points for the 4 corners of each of the rectangles, and then it draws that on the screen. You can also set up a default X step size and Y step size. When using the program, we actually found out that we needed different step sizes in the different directions because in terms of how far the beam moved, it didn't move nice and clean. So as you can see here, we can probably get about 5 using the current parameters steps across for each faceplate. And if you started at a different location, you might be able to fit 3, so maybe 3 by 5, or maybe you can make the step size a little bit tighter. Also, you can use the arrow keys to move from one faceplate location to another, which is fairly convenient. So yeah, it's kind of fun to play around with, at least watch the moving dot around. So orange is the old points and the blue is the new points. So in terms of features that I added, if we take a kind of look at the code here, I added the second rectangle. I removed the sleep component, and so it actually just kind of queries the microscope to see if it's done moving, which kind of speeds up the whole moving process. I added the config file, so it's a little bit easier to configure. It's a lot easier to find the 4 corners of the faceplate than it was using that Xmin and Xmap stuff from last time. I also separated the X and the Y step size. And because I removed that old Xmin Xmap interface from the thing, it really cleaned up the code. So here's kind of my standard things. We're connecting to PyScope, we're keeping track of the position history, set up the panel, create the font, read the config file, then go through the config file and find the max dimension. This is very useful if we take a look at the Python code here. We're much more zoomed in than the last code on the location of the faceplates. When I got to the microscope, I realized, we really kind of want to focus on that area. And at this point, I'm not actually checking to see if you're going too far away from the faceplate. I leave it up to the microscope to complain when you go too far. So, all right, so back to the code here. Again, it cleaned it up a lot because I have a lot less buttons. X step size, Y step size, up, down, left, right buttons. Bind them to appropriate functions, and then I do the layout. I have the input section with the step sizes, the quit and the update map buttons, the button pad, and then I merge them all together in the main sizer, create a status bar, fit things together. I have the components that read the configuration file, and I'm actually not using that. I just kind of pull it up directly. Set the bitmap because we're using WX Python. Maybe not the best choice, but I know it's the best. And I'm converting from a Python imaging library, or so-called Pillow now, to set the image data. You can set it from NumPy too, but I'm not using that function. Each function, move right, move up, down, move left. Angles are all 0 now. That's something we found out the faceplate was actually well aligned with the aperture direction, so we didn't really need to implement angles, which is probably the hardest part of my code last time. So for the most part, I set the angle to 0, and then step size is either minus step size or plus step size, and I notice I have X's for left and right, and Y's for up and down. And I also tell it the angle's direction is pi over 2, depending on which direction you're going. And then the move location function, I do the cosine and sine here, but it's a lot more simple than before. And then I tell the microscope to set the position, draw the status bar. New code here this is the code that checks the position to make sure it's actually gotten to the correct location. So it's just kind of measuring, has the position changed? Okay, I'll continue to wait before allowing the user to move again. Get position. When you get position of the microscope, it actually gives you the Z, but I told it to kind of ignore that. Also, when you set the position or sending it to the microscope, you give it X and Y. I confirm, make sure those are integers. Drawing the box is simple. I'm using, again, the Python imaging library. Create a new image, RGB. I set the image dimension to based on the distance of the faceplates. Draw a box, and then I can just get the locations for all the points, and then draw lines between all those points using the draw function. Make them red. Give them a width of half the diameter of our circles, and I draw all the previous locations in orange and the new locations in blue. Again, I am still flipping the image because I do like Cartesian coordinates with the 0 at the bottom left corner rather than image coordinates where the 0 is at the top left corner. And then I use that set bitmap function. I'm not using the rest of this code here for the most part. This just kind of launches the window. This is the quit button. This is not used. So anyway, fun program to write. Seems to be working. I do have a couple more things I need to implement. My feature set here is mainly logging, auto movements, and rather than having the user to manually do this every 1 to 2 hours, which means you can't collect data overnight. Using the faceplate right now, log the movements to the legend on database. I'm going to have to look up the code because I'm pretty sure we're logging the movements on the FEI scope, so we need to do the same thing on the JEOL scopes, or at least maybe store it in a position offline, maybe a text file, so people can look it up for the short term. Because connecting the legend on the database is going to be a little bit more work. Make sure I get it in the right location and it's easily accessible for users on the website as well. So anyway, that's my program. I hope you enjoyed me going over it, and I do enjoy making these videos. So if you have any other requests for the legend on Appian interface, I can do those. We are now again kind of working on the whole image shift for targeting empty holes. The microscope is proving to be a little bit difficult. So anyway, thanks for watching.